Today's lesson is on scientific notation. Now, scientific notation uses the properties of exponents, which we've had in the past, but let's do a quick review on the difference between a positive exponent and a negative exponent. If I give you 3 squared, a positive 2 exponent means I'm going to multiply 3 by itself twice and get 9. But if I give you 3 to the negative 2 exponent, a negative exponent means I'm going to do the opposite of a positive exponent. Positive means to multiply, so a negative means I'm going to divide by 3 twice. And what's always left in the top? A 1, which means it's going to be 1/9. Now, I really like to put a times 1 here in front so you know that there's this coefficient of 1, and that's actually going to help make sense with scientific notation. Scientific notation is going to be using positive and negative exponents on a power of 10 in order to make large numbers more compact and small numbers more easily writable, let's say, not compact. Let's do an example. If I give you the number 2,500,000,000,000, that's a lot of zeros to write. If I ask you to write that number a bunch of times, that just takes a long time to write all those zeros, to write the hundreds and the thousands and the millions and the billions and the trillions. So what we do, or what scientists and mathematicians have decided to do, is write this as a smaller number times 10, because if you'll notice, there's lots of zeros here. And what happens if I multiply a number by 10? It adds a 0 to the end, or moves the decimal more specifically to the right. So what they'll do is they'll say, all right, let's take the non-zero integers, the 2 and the 5. Let's put a decimal in between so there's only one non-zero decimal to the left. So in other words, this number here has always got to be in between 1 and 10, not smaller than 1, but not greater than 10. Now, if I times this by 10, what that does is it moves the decimal one place to the right, which makes it a larger number. It'd make it 25. If I multiply it by 2 tens, it's going to move the decimal twice and make it 250. So the question is, how many times would I have to multiply by 10 to get it to be the 2,500,000,000,000? Well, we need to count the decimals. So what I say is, okay, if the decimal's now right here, I've moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I put a 12 here. And that exponent means that I'm going to times this 2.5 by 10 12 times, or move this decimal over 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This number is the same as this number. It's just written in a different form. The top form is called the standard form. The bottom form is called scientific notation. Now that was a large number. Let's do a very small number. And what I mean by a small number is a lot of times when we talk about atoms and electrons and stuff, we have a number that's very, very close to 0. I don't even know how many in there is. 5, 6, 3, 7. Okay, so what we would do now is we would take the non-zero numbers, so that 5, 6, 3, 7. I would put a decimal in between the non-zero integer furthest to the left and the one to the right of it. So again, 5.637, it's larger than 1, but smaller than 10. But now what I'm going to do is I'm going to start not multiplying by 10, but you're going to go, Mr. Thorson, you wrote a times symbol there. But what I'm going to do is use a negative exponent. Because remember, what does a negative exponent do that we learned previously? A negative exponent means I'm not going to be timesing by 3. I'm going to divide by 3. So when I come back down to here, when I put this negative in front of whatever this exponent is, it's going to be dividing by 10. And when you divide by 10, it moves the decimal to the left and makes the number smaller. So if I did 110, it would be 0.5637. If I did 2 tens, it would be I'd move the decimal twice, which would make it 0.05637. If I did 3, it'd put another 0. So we need to figure out how many times I have to divide by 10 or multiply 10 with this negative exponent, which means divide by 10, to get it to be this top number that's written in standard notation. Well, let's find out. Remember, I moved the decimal from here all the way down to here. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I'm going to end up dividing that 5.637 by 10 13 times. And just remember, a negative exponent means I'm dividing by this number, which is 10, which moves the decimal to the left. So as a quick reminder, just remember, as you're converting back and forth between standard and scientific, if your exponent on the 10 is positive, your number is going to be a lot bigger than what you see in front of it. That 2.5 is going to be a lot bigger, which is 2,500,000,000, because I'm going to move the decimal 12 places. But if you have a negative exponent, you better have a small number way down into the decimals, because a negative exponent will move that decimal to the left a bunch of places.